architecture exists to create a physical environment. As an architect, our responsibility is not restricted or rather limited to designing a built environment, but also strive to deliver things of value and utility, with less resources quickly meeting the requirements of the individual. Adding more layers of aid for the architect is the construction industry that is entering a course of change now, giving opportunity to design new buildings with rather advanced and fresh practices.
Oh, it's yeah, yeah. Thank you. Uh, we've been in practice since 95, has already been spoken about, but when you start practice, one of the most difficult things is where do you begin, or any project for that matter. So it's not, you're seeing, what you're seeing as a presentation is not something that one begins with, but has been a kind of an accumulation of experience and knowledge, and working with colleagues, with lots of young trainees, and uh, so can I go back, please? Yeah. So just as clothes worn become one's second skin, architecture is often the third. When seen as such, one relates its inherent importance and deep relationship with the human body. Matter. All physicality is finally matter. The physical in architecture is the material that gives it body. The act traverse. The act of traversing, not as a mundane movement between point A and B, but does it provoke new possibilities and chance interactions? Relief. Architecture is an abode, not a machine. It is the immeasurable that is made tangible through relief. So these are, we are trying to characterize it into certain basics in a way you break up a project. Next. So if I was to explain skin to you here, this is a project, it is the corporate headquarters of a company that exports bed linen to Scandinavia. This is in Vatwa in the industrial estate. This is a blown up ISO, or yeah. And so I'll just quickly read this, where we had done a double wall kind of a system where the idea was to reduce air conditioning loads. So the courts, as well as so the main building is clouded within a singular wall, extra wall on the outer facade. Um, the skin is that which mediates between the real outside and provides an immeasurable experience of the everyday. We are in it all the time. It is that space within which we are private and social simultaneously. It is thus required to address far more complex realities. It is also through the possession of that skin that the body is experienced. And when I say skin in this context, you understand what I'm saying. It's that skin there. Next. In our geographies, how we mold, create, invent the skin is dependent on or arises out of our concerns of resources, material realities, climate appropriateness, technology, energy consumption, aspirations. So, do we see the skin as just an object that is just the cover? Or can it have all these things that we just talked about? This is a factory, the same corporate office that you saw. This is the factory behind, where you can see it's deep set windows. So the skin is made out of load bearing walls with red and fly ash bricks interspersed. This is the corporate office, where the courtyard on the south side is covered by basically a fabric structure, which is, what you call the green net. You get a gray net. It's actually that gray net. This is a small. Basically, it shades the court and allows a diffused light, and yet you get a court. This is a campus of a kindergarten where the louvers, basically the large louvers are two-floored louvers, which open and close depending on the kind of condition of the outside. So if it's outside is very pleasant, it's a large space on both sides, like this kind of a space, which has got louvers on both sides. So if the weather is beautiful, the skin opens up, and that's what that's about. And this is another kindergarten called Sheshya, which closed. We I think ran about 7-8 years. So this is a kindergarten where on the first floor we extended the space out and actually have a jali of bamboo, which again becomes a skin. There are no doors in the classroom, so the children can actually come all the way to the outside and look outside. Actually, it looks very dense, but from inside, when you look out, you can see quite a lot. Next. The skin mediates between the inside and outside, and its resolution marks this relationship. The act of its being is realized in the way the skin modulates, addressing myriad realities that are expressed through the articulation of its apertures. You understand what apertures are now? All our windows are apertures. The windows are the aperture of our walls, which is the skin. In this case, this skin has been. This is the factory where this is a double. The wall is load bearing, but it's been turned around in a way that it becomes a shaft. So the air moves in the shaft and is released at different levels and then exhausted out from the center. So the skin becomes a breathing skin, which actually gets fresh air from outside into the factory and deep inside. This is a large span. This is about 50 meters by 70 meters uh, with load bearing outside. So the outside skin is thick, it is solid, you can't see out except these deep windows, which you saw in the earlier shot. And the breeze is taken in through these shafts. So this is how the skin has been modulated. That's it's a detail of that. It's better explained here. You can see the thick wall, the breeze comes in through here and goes in and moves into the space and moves out from the center. This is what you see on the outside. The walls, and this is the basic structure. This is a three-floor load bearing structure. Next. These are just samples that we did. We wanted a passive cooling system that Dr. Chamanlal Gupta was helping us with. So these were various experiments. That's a close colleague, Raj, who's an engineer who we've been working with together for now 15 years plus. So this is basically, we did various experiments about which is the best way to allow the breeze to pass through these kind of surfaces so it cools down and then goes into the surface. So we did these cylinders of clay, like matka, but then we had problems of fungus on the outside. We realized maintaining would be a problem. We looked at mangalore tiles, we looked at brick in different layouts. Finally, we went for brick in this pattern. Next. So that was about skin. Now matter. How does one design something conceived with a material consciousness that nurtures the building through its life and enriches the same? The practice has been dabbling with this through the lenses of embodied energy, social equity, resources, maintenance, and building life. I don't know how many of you, and by now, I think this generation is supposed to understand embodied energy. And if you, you must check out what it means, because your next 40, 50 years is going to be all these areas that you're going to be having to work about. Yeah. So embodied energy is an extremely important concept. Keep that in mind. Social equity. Social equity basically is how much money do you spread out? Do you, so there is an X amount of money that you're spending on building a building. Out of what proportion of that building amount goes to skilled labor, artisans, craftsmen, or even labor, or a major amount goes to an industrial system? So if you use certain kinds of technologies, you'll probably paying an industry, a corporate. But if you use certain skills that exist amongst us, load bearing, simple load bearing skills, which give you a lot of other advantages. I mean, there are other ways you can look at it. I'm just using one example because that's the one we've taken. But there are so many other skills that are available in our system where you're able to actually create a huge amount of employment, uh, and along with that create a certain quality of experience when you're actually working through the making of this building. So this is sorry, this is basically an office that we did where we've done various things. This is jackards. We've done vaults, we've done domes. This is, I'll explain the jack arches, because vaults and domes, I think there are enough videos from the office on the net that you should all check out at some point for those of you interested. I'll explain the jack arch. For us, this was also the first time we did a jack arch. A fundamental anchor in all this has definitely been an overarching resource conscience that drives the practice to achieve grace in frugality. We try to see how we build without excess. If our structure doesn't require, basically, we do not need more than what is needed structurally. And out of that thinking, can the building still feel graceful, can still be evocative? That becomes one of our driving parameters. That do we need to add any extras beyond what is required to make it look as to? So this is basically, we've been working, we've been looking at materials in a very different way in various buildings, various different things. So we've been working with a very close friend, a material scientist. I would call him a material scientist, Keyur Kesarjan. He has done a lot of things, and we've been working with him for since 1996, 97. And this we produced with him. This is basically a brick that's made out of recycled brick waste, lime, and a little bit cement to bind, and clay. And these are water cured red bricks. So we've been using that for some time now in our buildings. This is a NGO in Alua where we've used timbrel vaults spanning 2 to 5 meters. And they're basically working floors. People can walk on them and sit on them. And that's that, which is fundamentally this kind of a system. What you see here, the timbrel vault on the last slide, I may be in somebody's way here. Those who can see the last slide here, it's an amazing system which can be easily proliferated. It's easy to train. It's very easy to build. It's a simple POP first layer, which is, and it doesn't require shuttering, doesn't require steel. And you can already see that fellow sitting on top when this thing is moving ahead. All these detailed videos are there on the net. I advise you to look at it. This is called Rotak Dome. Again, this is flat shell domes which do not require, again, shuttering and steel. And you can actually get large spans without steel and shuttering. And that's a big if. And this is Azad. This is from we just called it Rotak Dome because these masons, artisans are from Rohtak. Uh, they're amazing. One has to see them work. The way this stands, this is a little difficult skill to proliferate. It needs at least a year's practice working with the masons to move ahead. But they are very open. They come everywhere. Whoever calls them, they come, and they are graceful enough to come and actually build, travel, and build. Next. Continuing with the idea of material, basically matter. Uh, Collaboration with craftsmen, engineers, contractors, and other agencies have provided insights that allow us to refine the building product, what I explained earlier, uh, and make this a process, joyous process. The interactions constantly push us to re-examine construction practices and available skills, allowing us to add value to an otherwise rote process. You know, you can just simply draw a building and give it to a agency, and the agency will take it forward and build. There's enough expertise now on ground. Uh, everybody knows how to build walls, everybody knows how to put columns and beams and slabs, and so your job can actually be finished in your little studio. But it's up to you to decide whether you want to let somebody else enjoy it, or you want to partake in the joy of actually the process coming up. So how do you investigate? How do you become part of that? And I think that's the other thing. And when you investigate and when you begin to think about these concerns, you will start thinking about various ways in material can be harnessed to your advantage. So in this, like in this case, in the MIL factory, that large span factory I was talking about earlier, where it's a large span, about 10 meter spans, columns. You can see in the last slide. Uh, and there was a lot of concrete that would have, and I don't know if some of you may have done your structural engineering, I mean, class, all of us mostly must have slept, but for those of you who may remember, you actually don't need concrete through and through. There are parts where concrete is not needed. It's in compression, you don't need it. So you can actually remove concrete in those spaces. That's what is called technically a filler slab. So check out filler slabs, where you can actually save on concrete quite a big time. You can actually, you must have seen in earlier times, people used to put matkas, even put tiles, in the slabs. Though that's basically the idea of saving concrete. Now, in this case, the spans were very large, and we had 10-meter spans. So we actually made hollow blocks on site with fly ash and thermocol waste. So these are actually very lightweight. They're 50% thermocol, fly ash, and cement for binding, made on site, as you can see, handmade, and then put on top. So the shuttering is flat. So we are all the time we are also thinking about construction. uh, we can have a lot of beams. It's like this. If you have all these beams, imagine the shuttering in this kind of space, and the quality of shuttering along with that, then the plastering, a lot of things have to be taken care of. But if you were to do flat shuttering, and there's simply the speed of construction as well as finish, it was also a need of this industry, because this is a fabric, dealing in fabric, uh, and they didn't want any corners, so everything is worked out in a way that there aren't any edges. So it also helped us in convincing them, and we could experiment in this way. So this is what you see, this is what you get as the final product, bottom of this slab. And it's, I mean, so much of concrete is saved. Next. uh, Again, understanding construction practices, production practices, and resource constraint pushes us to innovate and inform the making. So it's like this in our own studio, where we've actually used a lot of bamboo as jalis, as doors, as boundaries between spaces. Similarly, in the same material, we've used as on top of the shuttering, we've used it as a texture giving. So what these carpenters are working for us here, and what you can't see it very well in this slide, but you actually, when you remove the shuttering, you get a fine grain bamboo texture on the roof. Similarly, the jali, and when the plant, I mean, when all the creepers are grown up on these jalis, it becomes a beautiful space from inside. You get the fragrance from into the room. So it's the same material in different ways, how it can be used. Just an example of that. Next. So I'll explain this jacquards a little in detail for those of you, because this is what I've realized. One of the things I realized is that when we started to do jacquard, this is one of the first time we've done a jacquard. We've done those other things 5-6 years before, but we've started really looking at alternatives in roofing only in the last 7 8 years, because for some reason information wasn't really available, in the sense it's not, structural engineers are not really used to this now. B, it's not that somebody's done it before you here in these parts. Some of this has been done in the south. A lot of people have been trying various things in Auroville. Uh, but when it comes to actually doing it in these parts, one hasn't found too much expertise. Uh, so one of the reasons we actually put out some of those videos, Timbrel was not anyway not very common. One of those detailed videos on the net was that these are things that should be proliferated and can be used by anybody. And if one looks at it, they're very easy to follow and continue. Same way, at some point, we'll probably be putting up this also, because we realize that actually it's one of the simplest things to build and use, but because of lack of information, I would even say it's not knowledge or it's not even abilities. I think it's simply information. These are things that can be done very easily. It's a resilient spanning system without concrete and steel, for a column-free space that reduces heat gain and ties the idea of material knowledge systems, construction speed, and economy. So these are basically horizontal beams on which I'll go next, please. I'll explain this as it goes. You can actually Oh, you can actually see this. This is the first layer. First brick is put in like this. The arch is marked, and then the brick is put, and then the next bricks, and then how the corners are filled in. So the arch is stabilized, the first one, and then you continue building the arches. So you can build up to, you can make that arch up to maybe a meter or so, and then the person goes to the next one, builds the next one, builds the next one. So couple of masons are continuously busy. And at the same time that it takes to build a normal slab, within less than time than that, one can actually do this whole thing at the same time. But fundamentally, the largest advantage we've found is it gives you a thick slab. Uh, by now, we all know that it's not the south, it's not the west that's real culprit. The real culprit is our roof, because the roof is sitting in direct radiation. It's like, how does your head get heated up in the sun? It's the same thing with buildings. The roof is the biggest culprit through which induction of heat happens into your walls and buildings. So if you are able to save your roof from heating up, or at least reducing the thermal gain somehow, you know this would be a major impact on the way. And so certain systems like these, other than skill and obviously quality of space, they're also helping you increase your thermal gain, or thermal lag, reducing thermal gain. So these are just slides which are showing those spaces. I'll go on that side. Is it easier? Yeah, much better. uh, so this is, so what happens is, when the fellow is actually, if you look, if he's actually here, but when he reaches towards the end, obviously he can't be sitting. So in the last 1 meter, we put up a small system like this, where you put up pieces of shuttering, which is in the form of an arch, and the last pieces are put up from the top like this. And so this whole thing is actually built on site, and this is the kind of space that you get. This is just a blow up a drawing of. So when we do all these detailed drawings with the idea of how many bricks, I mean, how many bricks and what kind of courses, because this is what you're going to see exposed. Can you go to the next, please? Okay, maybe we'll get that slide somewhere else. Oh, the first slide of this, I don't know how many of you remember, was actually of this building when we started with material. Uh, further, further. Yeah. So this is that space. Just to what you were seeing in construction, it was this space. Can you go now to? So the third last is basically the third part is about traverse. Uh, it's very simple. Architecture is static, but the user isn't. Right? One experiences architecture through traversing space. It is this traverse that creates joy, allows for the social, that connects the various experiences encapsulated in the building. So it is how you move through the building or to the building or around it. is as important as the others that we've been talking about. So this is a project, we won a competition in about 12 years ago. Hyderabad HMR, Hyderabad Metro Rail, was passing through a very dense urban neighborhood, like, I don't know, old city area, where you had a lot of vendors on the sides. And all those vendors and small shops had to be reorganized because they were refusing to move. And so they wanted to rehouse them, and they gave a site for a competition. And they said that we have to rehouse the space. So what we did was, obviously, this is a street where what are these vendors selling? They're selling things from 5 rupees to 50 rupees to 100 rupees, like things like belts, kerchiefs, spins, all kinds of everyday things. So which means people are continuously moving through the bazaar, and actually on the spur of moment you realize, oh, I need to buy some handkerchiefs, and you buy, or you need a belt, or you need some pins or whatever. And it's kind of pedestrians walking through a bazaar and picking up things and then moving into their residential zones. Now that was very important to understand. It is not like your regular shopping. So what we did was we created, it is a long site. It was 0.8 kilometer of that stretch here. What we did was we spun this building into basically we made a ramp of about 6 floors, which is a very slow ramp that goes up 6 floors, which gives us zero point 0.7 kilometers. So we are able to get 0.7 kilometers off the street in a vertical direction. Now we've got the street. We got the shops in the center. We got the vendors on the side of the street, on the outer edges of the street. We got a slow ramp. But that's not enough. It won't work if there aren't people. Why will people just walk up a building? So we connected this to the Hyderabad Metro Rail station. There are two stations nearby. So we were able to convince them. The building has just about, I mean, this is government scale projects, just about finished. I think last year or something, during COVID, I think it got finished. They haven't yet connected the corridors, but the idea was that you get off the metro rail, you walk in, and you walk down the fourth, fifth level down the building, and there are two levels of parking, which we were able to convince them to remove the cars and only put two-wheeler parking. So it was like the last mile connection. So you come down to the building, you take your cycle or scooter and go into your last, wherever in the neighborhood you live. So this becomes part of the neighborhood. So this is not about just designing a marketplace or a bazaar. It's about how does it get connected. It's all the dots that have to get connected into this uh, to make this work. So how does the act of movement allow one to connect, overlook, and hence activate? Can the corridor aspire to be more? I mean, all of us, most of us are used to, I mean, corridors are our everyday thing. No, we're always walking in corridors. One of the problems with corridors is they tend to segregate spaces horizontally. If I'm on the corridor on upper floor, the lower is something else. I don't know what's going on in the lower floor until I don't go to the lower floor. So they're basically segregated floors. And corridors are, other than the rooms, the corridors are really active spaces where people are meeting each other, going across spaces. In that space, can buildings begin to talk vertically? Simple thing, if you start thinking about it as an idea, then there are various ways one could. So we've tried our own ways, and there are so many other zillion ways one, I'm sure, once you start thinking. So this is the HMR complex I was talking about earlier, where it's a part section where you keep going up these 2 floors parking, and you walk up like this. The final floor is an open food court and an amphitheater on top with a large TV screen for sports and other things, while there is a food court. So this is that kind of thing where the idea of movement becomes shopping and other things. This is a school in Devisar, Kutch, post-earthquake. There was also this idea, this post-earthquake upper floors, people were not very comfortable about upper floors. So what we did was we connected the upper floor and the lower floor with a ramp. And the upper floor is overlooking this. So the upper floor can anyway overlook the lower floor, and it's an easy walk down into this space. So that's how this particular area of this corridor was looked at, one corridor overlooking as well as actually moving up to the first floor. Uh, this is a school we did in 1997, Anand Niketan Shilaj in Ahmedabad, where that is the first time we began to think about. This is a corridor on the south side, so we gave it a lot of depth because from the south came the rain and at the same time the sun. So we got deep veranda. Corridor becomes veranda, and also we wanted that we should be able to look down in different levels. So if you look at this corridor, so this is basically the way the corridor staggers and moves up and down. I can actually, right from the top, I can look right down 3.5 floors. There's a semi basement, so I can actually look down 3.5 floors. So instead of just a linear movement in the corridor, there are even cross movements and looking down. So that allows another whole dimension of experience for the children who are actually moving up and down. This is basically another school in Gandhinagar, Anandiketan, which was in about 2002, no, 2011, I think, and or late 2014 actually. And this is basically again the same way how the bridge connecting two buildings, the corridor becomes totally open and allows it to be looking at and through the bridge you're able to look at the two buildings because the way the two buildings are located, if I'm on the bridge I can actually be talking to the two buildings and to the ground below. So that's how the corridor begins to aspire for more in that sense. This is a kindergarten campus in Ahmedabad where the corridor, I was talking earlier about the skin. This is a four-floor building, but 2 floors lower. At the same time, it's also a corridor here. You can see how the corridor begins to do different things. Small windows, big windows, because it's a kindergarten, and there are different small nooks and corners in the corridor for the children to sit and move around. Uh, this is in the school in Hyderabad, the second one. The open space which is connected to the corridor on the other side becomes an amphitheater. Uh, the corridor sometimes, if it is gracious, can allow to be used by a teacher. This is a kindergarten in Hyderabad where it's a courtyard kindergarten, so there are a lot of small animals and birds also hanging out. So the children and the teachers, they love sitting in the corridors and working. This is Anandiketan satellite, where we had actually again looked at the idea of this is a 5-floor building, but the idea was how do you scale the corridor? So the levels of the corridor are broken. So you can see how the corridor moves out. And also the corridor steps back on the third floor and you can overlook further on and that becomes like a terrace. The corridor becomes a large terrace and there are 2 more floors above that. And so because of the curve, you're able to also look onto the corridor back. Just by a simple twist, I can see the whole corridor. The building is just curving behind me. So simple geometric moves can also make a corridor very interesting. Next, please. We come to next is relief. Now, what is relief? Finally, all of these things we were talking about are very rational, very objective uh, aspirations. What an architect does is something different from what an engineer potentially can do. And this is where I think architecture goes beyond the brief. And architects can do this. Your client will tell you 5 things. An architect can make those 5 things 10 things. The client didn't tell you that I want a corridor that actually I can look over. The the architect decides that. The client gives you a room for a certain purpose. The architect can say, hey, this is on the ground floor. I can actually open this and this